Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations.
Today, we're talking about AI teamwork. The idea of having multiple AIs, each with its own special skill, working together to solve a complex problem. You might have one AI that's a brilliant coder, another that's a planner, and a third that's a fact checker.
It sounds like the ultimate dream team, right? An assembly line of intelligent agents building something amazing. But in reality, these AI teams often fail, and sometimes in really spectacular ways. It's like a game of telephone gone horribly wrong.
Exactly. The first agent makes a tiny, almost unnoticeable mistake. It hands its work off to the next agent, which doesn't catch the error and builds upon it. That second agent adds its own little mistake, and so on down the line. By the end, the final result is complete nonsense. This is what researchers call a cascade failure.
And that's the problem tackled in a new paper called AgentAsk. Multi-agent systems need to ask. Researchers from several universities realize that the problem isn't necessarily that the AIs are bad at their jobs. It's that they are bad communicators. They don't stop and ask for clarification.
Humans do this all the time. If your boss gives you a vague instruction, you might say, "Hang on, when you say you need the report soon, do you mean today or this week?" AIs by default just take the information they're given and run with it, errors and all.
So the researchers came up with a beautifully simple idea. What if you put a supervisor between every two agents in the chain? A supervisor whose only job is to glance at the message being passed and decide, is this clear or do I need to ask a quick question?
And that's AgentAsk. It's a lightweight, plug-and-play module that does exactly that. It treats every single handoff between agents as a potential failure point. Before the coder agent sends its code to the tester agent, AgentAsk steps in and might ask, "Are you sure this code handles empty inputs?" It's a tiny intervention that can prevent the whole system from crashing later.
To build this, the researchers first had to understand the kinds of mistakes AIs make when talking to each other. They went through hundreds of system failures and identified four main categories of errors. Think of them as the four horsemen of AI miscommunication.
The first one is the data gap. This is when an agent just leaves out a crucial piece of information. It's like giving someone a recipe for a cake but forgetting to tell them the oven temperature. The next agent is forced to guess, and it will probably guess wrong.
Next up is referential drift. This is my favorite. It's the classic who's on first problem. One agent might be talking about variable x from the first step, but the next agent thinks it means variable x from a totally different part of the process. They're using the same words, but talking about different things, and the whole conversation just quietly splits into two parallel, incompatible threads.
Then you have signal corruption. This is when a wrong fact or a bad calculation gets introduced early on and is then treated as absolute truth by every agent that follows. Imagine a spreadsheet where one cell has a typo in its formula. Every other cell that depends on it will now be wrong, and the error just spreads and magnifies.
And finally, there's the capability gap. This is simply sending the task to the wrong agent. It's like asking the marketing intern to write the company's legal contracts. The agent might try its best, but it just doesn't have the right skills for the job, and progress grinds to a halt.
So AgentAsk is trained to spot the warning signs for these four errors. It learns from a powerful teacher model that shows it examples of what good and bad handoffs look like. Then it uses a process called reinforcement learning to get better on its own. It learns to balance accuracy with efficiency.
That's the key part, right? It can't just stop and ask questions all the time, or the whole process would become incredibly slow and expensive.
Exactly. It gets rewarded for asking a question that successfully prevents a cascade failure, but it gets penalized for asking unnecessary questions that just waste time. So it learns to be a minimalist. It asks the shortest possible question to the right agent, and only when it's absolutely necessary to reduce uncertainty downstream.
Okay, so the theory is great, it's simple, it's targeted, but does it actually work in practice?
It works brilliantly. The researchers tested AgentAsk on a range of multi-agent systems performing tasks in math, coding, and general knowledge. And across the board, plugging in AgentAsk consistently improves the accuracy and robustness of a system.
And what about the cost, the time and money?
That's the most impressive part. The extra latency and cost were all less than 5%. They compared it to the brute force solution, which is just using a massive, super powerful AI like GPT-5 to check everyone's work.
That's really effective, but it's also really slow and extremely expensive.
So AgentAsk gives you a huge chunk of that performance gain, but for a tiny fraction of the cost. It's the difference between hiring a full-time, expensive consultant to oversee your team versus just teaching your team members to ask smart, simple questions before passing on their work.
It's a really practical and scalable solution. As we rely more and more on AI to solve complex multi-step problems, we need them to be reliable. We can't have systems that design drugs or manage power grids failing because one AI forgot to specify whether a number was in inches or centimeters.
So the big takeaway from AgentTask is that for AI teams to succeed, they don't just need to be smart, they need to learn the simple human art of asking for clarification.
A little bit of curiosity can prevent a whole lot of chaos. It turns out that sometimes the most intelligent thing an AI can do is admit it doesn't know something and just ask.
That's all the time we have for today. Thanks for tuning in to Daily Papers.